Right now, as you are watching this, roughly 500,000 people are living inside the crater of a volcano that has been slowly inflating beneath their homes for 21 years. At 7:46 in the evening on Friday, the 31st of July, 2026, a magnitude 4.7 earthquake struck the Campi Flegrei caldera on the western edge of Naples. Italy's National Institute of Geophysics and Volcanology placed the epicenter near the Solfatara crater at Pozzuoli at a depth of roughly 3 kilometers. It was the strongest earthquake recorded in the area in 40 years. A magnitude 3.8 aftershock followed at 10 o'clock that night in the Gulf of Pozzuoli, part of a swarm of more than 30 tremors through the evening, with more than 60 aftershocks reported in total. At least 21 people were injured, 2 seriously. Rail service across the Naples network was suspended. The port of Pozzuoli was closed, cutting ferry service to Procida and Ischia at the height of the summer season. And here is the detail that matters most. The June 2025 magnitude 4. 6 was described, at the time, as the strongest in 40 years. The July 2026 event surpassed it. This is not one anomalous night. It is a ladder of successive records climbing alongside 21 years of ground uplift. So today we are going to break down exactly what happened, what Bradyseism actually is, why this caldera has already run 2 full crises that ended in nothing, and, most importantly, the specific measurable signals that would tell scientists this one is different. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now and tell me this. Have you ever visited Naples, Pozzuoli, Ischia, or the Amalfi Coast? And if you have, did anyone, a guide, a hotel, a sign, anything, tell you that you were standing inside an active volcanic caldera? I genuinely want to know, because millions of people visit this coastline every year, and I suspect the number who were told is close to 0. If you want to be the first to know every time the alert level on this caldera changes, subscribe right now. It is completely free. A thumbs up helps enormously. Let us go for 5,000 likes so the algorithm pushes this to the people who live there and the people who are about to book a trip. Let us start with the geography, because the name confuses everyone. Campi Flegrei, the Phlegrean fields, the burning fields, is not a mountain. That is the single most important thing to understand about it. There is no cone, no summit, no obvious peak to point at. It is a caldera roughly 12 to 15 kilometers across, a vast collapsed basin created when previous eruptions emptied the magma reservoir beneath, and the roof fell in. Naples sits on its eastern rim. Vesuvius, the volcano everybody has heard of, sits on the opposite side of the city entirely. Inside that basin are towns, ports, motorways, a football stadium, Roman ruins, and hundreds of thousands of homes. 15 municipalities lie within the designated red zone, with a combined population exceeding 500,000. The caldera floor is farmland and apartment blocks. People commute across it. That is why the most dangerous volcano in Europe does not look like a volcano at all. And it is worth pausing on the title itself, because 2 Italian volcanoes compete for it and they are dangerous in different ways. Vesuvius has the reputation. It destroyed Pompeii and Herculaneum. It is visibly a mountain, and enormous numbers of people live on its flanks. But Vesuvius has been quiet since 1944, and its hazard is a future event nobody can date. Campi Flegrei is the one that is measurably moving right now, today, with instruments recording it week by week. One is a loaded weapon in a drawer. The other is a system with a needle currently in motion. That is why volcanologists watch this basin the way they do. Now let me explain the mechanism, because Bradyseism is genuinely unusual, and it is the whole story here. The word comes from the Greek for slow movement, and it describes exactly that. The ground surface of the caldera rising and falling over years and decades. Not shaking. Rising. The best physical evidence in the world for this phenomenon stands on the waterfront in Pozzuoli, 3 marble columns from a Roman market building, each carrying distinct horizontal bands of holes bored by marine molluscs several meters above the present ground level. Those columns were built on dry land, sank below the sea, sat there long enough for shellfish to drill into them, and then rose back into the air. Nobody moved them. The ground did it. Picture the system as a layered cake under a glass dome. The cake is a stack of weak, porous volcanic rock saturated with hot water and gas. The dome is a caprock, a tougher, less permeable layer of altered tuff and clay, sitting roughly 1 to 2 kilometers below the surface. Below all of it, somewhere between 4 and 8 kilometers down, sits a body of magma that is slowly degassing. When that magma releases heat and gas upward, the hot fluids pressurize the layers beneath the caprock. Pressurized fluid expands the rock volume, and the surface above it lifts. As the caprock is stressed, It fractures, and each fracture is an earthquake. That is why the earthquakes here are shallow, frequent, and concentrated in a small area. The July 31st event was at 3 kilometers. In the 1982 to 1984 crisis, seismicity occurred mainly in the Solfatara Pozzuoli area at depths shallower than 3 kilometers. And now let me address the number, because the number is being misread everywhere. A magnitude 4.7 is, in global terms, a modest earthquake. What made this one damaging is depth and geology. At 3 kilometers, there is almost nothing between the rupture and the buildings above it, so a moderate release of energy arrives at the surface with very little attenuation. Much of the reported damage came not from structural failure of houses, but from collapses of the rock faces that border the caldera's craters, debris landing on cars and railway tracks, plus the failure of already condemned. Unoccupied buildings. Here is the part that offers real reassurance, and it is rarely explained. There is an effective ceiling on the earthquakes this system can produce. Large earthquakes require cold, strong, brittle rock capable of storing enormous elastic strain over centuries before releasing it. The crust under Campi Flegrei is the opposite. Hot, fractured, saturated, and weak. It cannot hold that much strain. It fails early, and it fails often. That is why 21 years of unrest have produced thousands of earthquakes, with a maximum in the mid-4s, rather than one catastrophic event. The ground here is not a locked fault. It is a cracked lid. The trade-off is that a cracked lid produces damage continuously in a densely built environment, which is exactly what residents of Pozzuoli have been living with. Now let us do the comparison that decides how frightened to be, because this caldera has already run the experiment twice and produced two opposite answers. Between 1969 and 1972, the ground at Pozzuoli rose by roughly 1.7 meters. 3,000 residents were evacuated from Rione Terra, the oldest part of the town. In 1970, there was no eruption. Then, beginning in November 1982 and ending in December 1984, it happened again and harder. Approximately 1.8 meters of uplift, more than 16,000 earthquakes, with a maximum magnitude around 4.0 in October 1983. Buildings cracked across the town. Scientists at the time recognized the pattern as resembling the lead-up to the caldera's only historical eruption, and the authorities acted. Roughly 40,000 people, effectively the entire town of Pozzuoli, were evacuated, and a substantial share were permanently rehoused in a purpose-built new town, Monte Rusiello, on higher ground outside the worst-affected area. There was no eruption. The unrest subsided. The uplift reversed into subsidence. 2 full crises, more than 3 meters of cumulative ground movement, tens of thousands of people displaced, and the volcano simply stopped. That is the single most important precedent in this entire subject. Unrest is not eruption. A caldera can inflate by meters, shake for years, and go back to sleep. But now the other side, and it is the reason nobody in Naples treats this casually. The last eruption at Campi Flegrei was in 1538, and its precursors were the same phenomena, running longer and finishing faster. After centuries of gradual subsidence, the caldera floor began rising in the decades beforehand. Residents of Pozzuoli noticed new land emerging from the sea as early as 15002. The uplift accelerated through the 1530s. Contemporary accounts suggest total uplift on the order of several meters near what became the vent, with the shoreline pushed out by hundreds of meters. Then, over roughly a week, an eruption built an entire new hill, Monte Nuovo, New Mountain, which stands today as a nature reserve. You can walk up in half an hour. So the honest position is this. The 1538 eruption looked like this at the start. So did 1970. So did 1983. 2 of those 3 ended with nothing. Which brings us to the question the title of this video actually promises to answer. What would tell scientists that this time is different? There are 5 signals, and they are specific. Before the list, one piece of context that changes how you read all of it. There is a genuine, long-running scientific debate about what actually drives the uplift here. One family of models attributes it primarily to magma pushing upward and pressurizing from below. Another attributes it primarily to the thermodynamics of the shallow hydrothermal system, hot water and gas expanding beneath the caprock, fed by heat from a magma body that is not itself moving. Work on the 1982 to 1984 crisis concluded that magma chamber overpressure alone could not account for all of the observations, and that disturbances of the shallow aquifers, driven by increased heat flow from depth, explained the data better. That distinction is not academic. Under the fluid model, unrest can inflate a caldera by meters and then stop, which is exactly what happened twice in living memory. Under the magma model, unrest is an ascent in progress. The 5 signals below are in effect, the tests that would tell you which model is describing the present. The first is the uplift rate. INGV currently reports ground deformation of approximately 10 millimeters per month, sustained for over a year, with total uplift exceeding 140 centimeters since the current phase began around 2005. Now do the arithmetic against 1982 to 1984, roughly 180 centimeters in about 25 months, which averages out near 75 millimeters per month. The current rate is a fraction of the rate during a crisis that ended without an eruption. A sustained acceleration toward those 1980s figures, not the total, the rate, would be the first genuine escalation. The second is where the earthquakes are happening. Right now, they are shallow and spread across the Pozzuoli and Solfatara area, consistent with fluids fracturing the caprock, if hypocenters began migrating upward over time. And if they concentrated into a narrow vertical column beneath one specific point, rather than a broad area, that is the signature of magma making a pathway rather than fluids stressing a lid. The third is gas chemistry. INGV samples the fumaroles continuously and reports long-term trends of hydrothermal system heating and increased fluid emissions. The escalation to watch for is a shift in the composition, a rising proportion of sulfur dioxide and other gases that come out of solution only as magma decompresses near the surface, rather than the carbon dioxide and steam signature of a hot water system. The fourth is tremor. Discrete earthquakes are pops, rock breaking. Harmonic tremor is a continuous rhythmic signal, and it typically means fluid or magma is moving through a conduit rather than rock simply snapping. Sustained tremor would be a major change. The fifth is the alert level itself, and this is the one anybody can watch without a degree. Italian Civil Protection operates a 4-level system for the Flegreian fields. The caldera currently sits at yellow, attention. The step above it is orange, pre-alarm, and the step above that is red, alarm, at which point the evacuation plan for the red zone activates. That plan exists, it is published, and red zone municipalities are formally paired with other Italian regions that would receive their populations. The alert level is not a mood. It is a defined threshold tied to monitored parameters. So when you see headlines calling this a super volcano about to destroy Europe, the instinct is to assume a civilization-ending event is loading. Is that what the science says? The honest answer is no, and the framing is genuinely misleading. Campi Flegrei has produced 2 enormous caldera-forming eruptions, the Campanian ignimbrite about 39,000 years ago, and the Neapolitan yellow tuff about 15,000 years ago. Those events are why the caldera exists. But in the 15,000 years since, the system has produced more than 70 eruptions, and the pattern has been a progressive reduction in eruptive energy, with vents migrating toward the center of the caldera. The last one built a hill you can climb before lunch. Nothing in the monitoring data points toward a caldera-forming event. INGV consistently frames the current state as accelerating unrest and uplift, explicitly not an imminent eruption, and its weekly bulletins have repeatedly stated that no significant short-term changes are anticipated based on current activity. Caldera unrest is common worldwide. Yellowstone, Long Valley, Santorini, Rabaul have all inflated, shaken, and stood down. And the large majority of documented unrest episodes end without any eruption at all. What has actually changed here is not the volcano's ambition. It is that 500,000 people, a metropolitan rail network, a working port, and a UNESCO-adjacent tourist economy now sit on a caldera floor that moves. Let us be direct about the practical message here, because information without action is just anxiety. 1970 and 1983 show a state that evacuated tens of thousands of people on precautionary grounds for eruptions that never came, and got no thanks for it, but lost nobody. 1538 shows what the same warning signs look like when they do not stop. July 31st shows that the real, present, ongoing hazard is not lava. It is a magnitude 4. 7 at 3 kilometers depth under old masonry, cliff faces above roads, and a rail network people use to get to work. Here is what you can control. If you live inside the caldera, find out which zone your address is in, red or yellow, because they carry completely different plans, and know which region your municipality is paired with for transfer. Keep documents, medication, and a bag ready, because the events that actually displace people here are earthquakes, not eruptions, and they arrive with no notice at all. Learn whether your building has been assessed, and if it is old masonry, ask what has been done about it. Know that the greatest injury risk in these events is falling masonry and rock at the moment you run outside. The safest immediate action is cover, then evacuate after the shaking stops. If you are visiting, check the civil protection alert level before you travel. Understand that ferry services to Procida and Ischia can be suspended without warning, and take the 10 minutes to look at Pozzuoli's Roman columns, because they are the clearest lesson in geology anywhere on Earth. Final thought. This caldera has been rising and falling for thousands of years. Roman engineers built a market on ground that later sank beneath the sea and then rose again with their columns still standing. That process did not begin with us, and it will not end with us. We cannot stop Bradyseism. We cannot tell you whether the current phase ends the way 1972 and 1984 ended, or the way the 1530s ended. What we can do is exactly what Italy has already demonstrated is possible: monitor a caldera with seismic, geodetic, thermal, and geochemical networks continuously, publish weekly bulletins in the open, define alert thresholds in advance, and move 40,000 people when the data says to move them, accepting that the reward for a correct precaution is that nothing happens and everyone complains. Pozzuoli showed the world what evacuating a city for an eruption that never came looks like. Monte Nuovo shows what happens when the signs do not stop. The 5 signals are published, measurable, and being watched every single day by people whose entire job is watching them. That is a better position than almost any population living on a volcano has ever been in. The open question is not whether the ground will keep moving. It will. The question is whether 500,000 people know which of the 5 signals to look for, and what they are supposed to do the day one of them changes. We will keep tracking every bulletin as it comes. Subscribe so you do not miss it. And leave that comment below. Have you been to Naples? And did anyone ever tell you what you were standing on? Because these are not just geological events. They are human decisions.